This video was inspired by a blog by Kelly O'Shea, who's a high school physics teacher. She has a whole experiment about bouncing Tic Tacs. And that further inspired one of my favorite YouTubers, Physics Girl, to do her own experiments.
Sometimes Tic Tacs bounce higher on the second bounce than on the first.
What? Our brains have a pretty good intuition for how dropping things works. Even if you start high, you'll end up getting lower and lower and lower as things bounce. How do you know this video is being played in reverse?
Because you have an intuition for how balls bounce. They start high and they get lower and lower. This is called the conservation of energy.
Energy can't come out of nowhere, but it can be transferred between different kinds of energy. Let's take a look at the skater. Look how fast it goes at the bottom. At the bottom, all of its energy is in speed. We call it kinetic energy. At the top, it's not moving at all. Its speed is almost zero. It is zero at the top. All of its energy is in gravitational potential energy. But that gravitational potential energy, all this blue part in this pie chart, didn't come out of nowhere. It got transferred from the kinetic energy. Watch these get transferred to each other. It's all gravity now. And then it goes into kinetic energy. And then that kinetic energy goes into gravitational energy. And when it falls, that gravitational energy goes into kinetic energy. Energy isn't created and it doesn't come out of nowhere. It gets transferred from one type to another. Let's take a look at Physics Girl's slow motion video to find out more about what's going on with Tic Tacs. We've forgotten about an important form of energy, rotational.
And so I began my journey to search for, hold on, let's just stop for a second. It's Christmas, that's why I'm dressed this way. As I was saying, I began my search for objects that when bounced would rotate. Maybe those would also bounce in mysterious ways. I already tried a golf ball, so here's a ping pong ball. But it looked like round objects bounce in mostly predictable ways. So I tried a Kinder Egg, hard to predict, a football, even harder to predict, and then I found ones that could reproducibly jump higher on the second bounce. Boom, dice.
All right, let's bring this down to the action replay. Here's our die. Look how high it is. It has a lot of gravitational potential energy because it's so high up. But as it falls, look at its speed up. As it's falling, its gravitational potential energy gets transferred to kinetic energy. It's falling fast. Now, right before it hits the ground, it's going very fast. So all of its energy is in translational kinetic energy. Now watch what happens. It hits the ground at an awkward angle. Do you see that? Before it hit the ground, it's falling and not spinning at all. And now it's spinning. Notice how much slower it's going. What we're seeing at this very moment is energy being transferred, okay, from translational kinetic, moving down fast, to rotational kinetic energy. These big yellow bars are how fast it's spinning. It does not have as much energy to move up anymore because most of its energy is going into spinning it. And it's spinning pretty fast. Check this out. That's pretty cool, ain't it? Alright, so now it's spinning. It's going down. It's about to hit the ground again. It's about to hit the ground right here. When it hits the ground, it hits it at an awkward angle again. Check this out. Here we go. Boom. Do you see that? What happened to its spin? It was spinning boom, hits the ground and it stops spinning. It hits the ground at a perfect angle that enacts a torque on it and makes it stop spinning. That's what's happening right here. All of its rotational kinetic energy from spinning goes back into translational kinetic energy. It can now go high. Look how high it's going to go. Boom, all the way here. It's got all this gravitational potential energy now.
So today we learned about rotational energy. And if you see something moving in a funky way, it might be because it's also spinning. I'd like to thank my professor, Dr. Milner Bolton, for supervising me on this, and the UBC Faculty of Education. But most of all, let's thank the inspiration of this video, Kelly O'Shea. Check out her blog. Check out Physics Girl on YouTube. And as always, check out PHET, P-H-E-T. It's the best online simulators for physics. And don't forget to stay curious.